Let me tell you about symbolic links in Linux. A symbolic link is basically a file that points to some other file or folder on your computer, just like a Windows shortcut file. When you perform an action on a symlink, the action is forwarded to the file or folder that it is linked to. So for example, when you open a symlink, the file that the symlink is linked to is opened instead. A simple concept, right? Now let's take a look at this web application. As you can see, it offers a file upload functionality, and as the application says, it only accepts zip files. No problem, let's create one. First, I'll create a text file with some text in it, and I'll name it sample.txt. Then I will use the zip utility to create a zip archive with this text file in it. Now let me upload this zip file on the website. It says file uploaded successfully. It doesn't display the uploaded file, but it just says the file is uploaded. Since the website is only taking zip files, there is a high possibility that the uploaded zip files are being unzipped on the server so that the code can process the files inside the zip archive. Our first task is to find the path where the zip files are being unzipped. So let me fire up GoBuster to discover directories on the web server that are not publicly visible. I'll start a directory scan by giving the URL of the web app as the input and also the word list that I want to use. And soon enough, we found some directories on the web app. The last directory, called extract, is interesting. It really adds to our assumption that the zip files are being unzipped on the back end. When I try to access this path on the web app, I get this message saying that the access is forbidden. This is probably because the directory listing is disabled on the web server. So we cannot list files by going to a path in the web root. But we can still access files provided that we know their exact path. Coming back to the output that the web app gave us when we uploaded a zip file, you can see that it also displays a seemingly long random string. This looks like a hash, and it is potentially the hash of the uploaded zip file. Let's cross-check it. I'll calculate the MD5 hash of the zip file on my local machine with the help of the MD5sum Linux utility. And as expected, the values match. So we can now assume that the uploaded zip file is being unzipped to a directory that is named after the MD5 hash of the file. If I directly go to this directory from the web root, it says the resource is not found. So I'll first go to the extract directory that we found earlier in our GoBuster scan and then append the file hash to this. And the web app responds with a forbidden message like this. And that's a good news because it means that the path actually exists. We are just denied access to it because the directory listing is disabled on the web server. I will go one step further by appending the actual file name of the file inside the archive, which is sample.txt, the text file that we have created at the beginning of the video. And voila, we are able to read our text file, which is inside the zip archive that we uploaded. So this is what we know so far. The website only accepts zip files. After uploading, the zip file is extracted to the path extract / followed by the MD5 hash of the zip file. We can access the extracted files by going to this path followed by the actual name of the file inside the archive that we want to read. Now that we understand how this web app works, let's use our knowledge of symlinks. I'll create a symlink on my local machine that points to /etc/password file, which is a world readable file and it exists on all the Linux machines. Now I'll create a zip archive with this symlink file with the tag symlinks option that tells the zip utility to treat symlinks as symlinks. And now I have a compressed zip file that contains a symlink which points to the etc password file. I'll upload this file to the website and then go to the respective path to access my unzipped symlink file. And what is that? That's the contents of the etc/password file. Not just any etc/password file, but the one that exists on the server. That's right. This means we are now able to access files outside the web root, which we are not supposed to access. So any file on the server that the web server process can read, we can also read using this vulnerability. Let's try to read some sensitive files now, like the Apache web configuration file, which may contain environment variables that are used by this web app. To do this, I'll create another symlink that points to /etc/apache2/sitesavailable/000default.conf, which is the default path of the Apache configuration file in a default Apache web server installation. I'll once again create a new zip archive with this symlink and then upload it to the web app. Once the file is uploaded, I go to the respective path of my new symlink file. And I can see the Apache configuration for this web app. And just like we imagined, there is an interesting environment variable that contains a potential password. It is not uncommon for developers to store sensitive details like database credentials in environment variables so that the application code will be able to access them whenever required. And in our case, we found an environment variable called database password in the Apache configuration file. And it is also not uncommon for developers to reuse passwords. We are all humans after all, and we all tend to keep things simple, like using the same password on multiple services. So with a password in our hand, we can try to spray this password on multiple services to see if we successfully authenticate with any of them. And in this case, this password also happens to be the SSH password for the user named dev. So I can simply log in to the server via SSH using the password, and just like that, I have a shell on the server. This is called a directory traversal vulnerability because we are able to traverse the directories outside the web root using symlinks. Most of the people confuse this type of vulnerability with local file inclusion, but this is not an LF5 vulnerability because in local file inclusion, we would be able to include an arbitrary file in the application's running code. And by doing so, we can even achieve remote code execution in particular scenarios. But that will be a topic for another video. Thanks for watching. That will be all for this video. If you did like this video and if you learned something new, please do not forget to leave a thumbs up below and also leave a comment in the comment section. If you're not yet a subscriber, please do hit that subscribe button and also turn on the bell icon to receive instant updates from my channel. I'll see you in the next video. Until then, cheers.